Got it.
Got it?
Got it. I think we all got it. There's 5 of us. There's 5 of us on the screen for the big Monday morning SBAU hour of astronomical events and things. We like to meet here even on a rainy day in California. It's either one thing or another, the fires or the rain. We got 4 1/3 of us on the screens. And my name is Baron Ron Heron, and doggone, it's good to have you aboard. Our 35th episode of the old podcast for the Santa Barbara Astronomical Unit, keeping the club alive, both as a radio show, as a Friday luncheon at Judge for Yourself, and as our meetings, which we, I don't know, may never have again, but the the museum, it's behind the mission. Welcome aboard. I'm the vice president of the club somehow. I don't know how I did that, but I'm Baron Ron Heron. I'm going to introduce you to the president who managed to get back on his regular one. Good morning, Jerry Wilson. How'd you do that?
Jerry, you're muted. You're muted, Jerry. We can't hear you.
Yep. Oh, that's the problem I had last week.
Oh, he's having communication problems too. He's breaking up.
Maybe he's getting one of those dreaded updates. That's what killed mine. Maybe you want to try get it back on your cell phone if that's not what we're on. I think cell phones are always narrow, aren't they?
Well, he's using his iPad tablet, and then I'm not sure which data link he's using, maybe through his cell phone, which may be limited. So
we'll meet him in a moment. That's the president there.
Well,
Okay,
now he's unmuted.
I think I'm unmuted now.
Yes, you are. Good morning, sir.
Good morning.
All right. Are we on regular or?
You're on my data link to my iPad.
Oh.
Over the phone lines.
Well, I hate to say it, but you never look better. Up in the corner on my
Thanks,
screen.
I think.
What? Yeah, the webmaster. Let me introduce you to everybody here. First of all, ladies and gentlemen, the man that gets us on, Tom Cotton. Thank you very much, Thomas. Got a lot to jury rig today because we don't have any talking points technically, but believe me, once we get going, we'll talk. We have our incredible outreach coordinator, ChuckMcP, also married to a Pat.
Morning.
Tom is married to Suzanne, an artiste, and we got Pat Forgy, who is Mrs. Wilson, and Mrs. McPartland is also our merchandise manager. And joining us also on Zoom screen is Tom Whittemore, who's our token maker. Tom, good morning to you, sir. Jerry, while we got you on the phone, let's talk about what we may talk about. You had a meltdown of your modem. I had a nasty update last week. There's always something with this modern technology. Any ideas where you'd like to lead us this hour in chatting about our favorite topics? Jerry, you locked in on the screen.
We froze again.
He froze.
it must be cold over at his house.
I guess his mute froze too. All right. Well, I did not get to one item that I had transcribed all of last week. Well, hello, Bruce Murdoch. Let's introduce him. Are you on? You're working. Jerry, you got time to jump in that Tesla and drive over to Bruce's house, and then you can both get on
Tom's house.
He's locked in. We're always have problems with these damn things. Anyway, this is Bruce Murdoch, longtime active member, president of the Santa Barbara Theater Organ Society. Not sure how you guys are doing. Are there any meetings or problems that are going on?
No, COVID is pretty well squashed all of that.
COVID has pretty much knocked down everything. Whittemore, are you baking bread?
I baked 2 ryes this morning.
Ooh, you're back to ryes.
Yeah, I'm doing a lot of rye lately.
All right. Well, Jerry will possibly rejoin us, maybe on a little slim screen from his.
Tim Crawford has joined the chat group on YouTube.
Oh,
so
nice.
He's saying, ask Tom Whittemore about the Henrietta Levitt in Sky and Telescope. Henrietta Levittown.
No,
Okay.
just Levitt. It's just Levitt.
Levitt.
Yeah. Oh, must be. Yeah. Just kind of.
So, yeah, okay. You want me to say
Levitt.
something? There was a fabulous article and again, it's a December issue of Sky and Telescope about Levitt, Miss Levitt. And she was one of the Harvard, quote, computers in the early 1900s, late 1800s, who she basically noticed how you could use variable stars to tell distances. Okay, it's a fantastic article. It's written by Davis Sobel, who's written several books. It caused me to pick up another book I've had for years here by a fellow named Johnson called Miss Levitt's Stars. Fabulous book. It's a little thin book. It's all about her story and the story of basically being able to tell how far away galaxies were by looking at stars that vary in brightness in those galaxies. Okay, so she was one that noticed this, and it was taken advantage of by Harlow Shapley, Hubble. Eventually took advantage of this.
Basically, one of the fundamental ways that we measure distance.
That's it. There she is. That's Henrietta Levitt. Swan Levitt. She was never married, but she used her mom's name.
So she preceded Hubble?
Oh, yeah. Yeah. So she was born before the Civil War, if I remember right. And then unfortunately died of cancer in 1921. And it's interesting in the article, I never heard this before, that the Nobel Prize, they wanted to give it to her, at least interview her for the Nobel Prize, but she'd already passed. And so you cannot give the Nobel Prize to posthumously. But But she was the one who, studied these variable stars called Cepheid variables, especially in a small Magellanic Cloud. And so she was able to relate the peak brightness during the cycle, okay, to how bright the stars would be innately. And if you know how bright a star will be innately, and then you measure how bright it looks, then you can tell how far away it is by the 1/r² law. Yeah, thanks, Tim, for bringing that up. It's a fabulous article, really good article.
Yeah, because of that period luminosity relationship, if you can measure the period of the star, you know how bright it gets, and then if you know how bright it appears, you know how far away it is.
That's it.
There's confounding factors like dust and things like that, but it's a primary way of measuring distances out to something like 300 million light years with Hubble.
Right.
But the Cepheids are different from the occasional variable star that we honor here on the program.
Variable stars is a generic term, and there's all different kinds, and Cepheid is just one kind.
Right.
Okay. Well, it seems to me we've never had a variable that was a Cepheid.
Sure.
Jerry,
North
are you
Star
with
is
us?
one. Or North Star is one.
Can you hear me?
Not
Can you
great,
hear me?
but we can hear you.
You are breaking up.
Oh, Polaris is the North Star. It's a Cepheid variable.
Right. Mm-hmm. That's
Gotta
probably
tell
the
you-
most famous Cepheid variable.
It's also a double star.
Yeah.
Hate to tell you this, Mr. President, but this is how you're going to sound real life in about 10 years from a wheelchair. Good Lord.
Yeah.
Well, talk to us, Mr. President. What would you like to do? You'd like to continue the series on photon detection?
I don't think my connection is stable enough to get through a long talk like that.
Okay.
But I did notice that an article that I was going to include for today's talking points is that they
Lost you.
Yeah.
You
It's
Try
just breaking
again.
up, huh?
We didn't get that, Jerry. It broke up.
Totten, is it possible to call up one Halloween
asteroid
card?
Bennu, a common type now they've decided.
There you
Okay,
go.
never mind.
Well, no, you were off and running there.
We
Tell us.
pretty much just heard Bennu at the end there.
Oh,
Can we take up a collection and buy you a new modem?
no, my IT department is in there working on trying to get our new modem. The old modem died. Trying to get the new modem, Netgear, working.
Aha. Well, that'll be next on my agenda, I got to tell you. Totten, at some point, if you want to try to find the Halloween cartoon, I know it's not about astronomy, but it was kind of funny.
I got it somewhere.
The
Hold
guy
on.
sent to us. I'll
Doing
tell
it
you
since
basically
Saturday
what
night.
you're going to see as we take a little interlude break here. It is the season, and these suckers are out in the field waiting to be picked up, and they're talking. Big Halloween cartoon from President Jerry sent to us. A bunch of big orange pumpkins are talking in the background. One of them says to the other, we're going to get it here.
Yeah, here it is.
Check out Ned. Dude needs glasses. He's chatting with a damn basketball, for crying out loud. Never thought of that, but that's the color of a basketball. And Try to put eyes in them, and it's no longer a basketball. Thank you for that, my friend. Are you with us, Mr. President? No, he's not. He's gone again.
So I'm here.
All right, he's trying. Me, I just gave up last week.
Ron, you
yeah.
you had complained about Microsoft at all upgrading your computer and screwing things up.
Updating.
Well, whatever.
Yeah, that just.
And I have mine set up so that it can tell me an update is available, but it can't do it. I have to say do it. And I go out and look at what a lot of them are, and I say, I'm not interested in that. I'm not going to do it, so I don't do it.
They tell you what's going to be sent, what it's all about?
Yeah, you can say, the details, and they'll go out and tell you all about what it is. And I say, I don't even use that. Why do I want to upgrade that?
Well, Totten had told me that I can call it up anytime I want, and I should have done it this morning, but I had no idea. Something on the taskbar at the top or something.
You go to settings on the Windows machines, and there's an update section you click on, and you can check for updates.
Well, I just figure it's a power bigger than me, and when it shows up and wants to take over, I let it do it, and I sit back and abort everything else I was talking about. Jerry, you're still trying.
Yeah,
can you talk to us? You look good.
He's trying to put data, video, and audio over a weak data connection through his phone, I guess.
Right.
Well, does he know about your secret tie-in to the electric cars you guys both bought?
Here's my IT expert.
Aha.
Well, we saw Honey earlier. Is that your IT expert?
Honey? I didn't get that. What is that about?
That's his dog.
It's a dog.
Well, we saw the car.
No, the dog.
Oh, the dog. I thought you said car. I'm sorry. Okay. Well, can those cars you bought leave rubber if you wanted to peel away and you wouldn't hear a thing?
Okay, let's do astronomy.
Yeah, sounds good, Chuck.
Well, we're going to have to plunge ahead, I guess, without Mr. President. He's trying. My God, sounds. Open the pod bay doors.
Sounds like a steel drum.
Yeah. I thought he was talking through a banjo.
Oh, absolutely.
Well, you want to talk about Lucy in the Sky with Diamonds? I had that up for grabs last week, since about a week and a half ago, they launched on a 12-year trip out to the Jupiter orbit. And I could stand to learn, ladies and gentlemen, a lot more about the Trojan asteroids that they're going to try to intercept. Here we go. Who knows more about it than anybody? Chuck, you want to start the ball rolling? What's it called?
Well, they've called the mission Lucy because they're going out to look at these Trojans trapped in the Lagrange points of Jupiter's orbit. And they think these might be leftovers and unmodified from very early in the solar system. So it's looking back in time. And they named the mission Lucy after the hominid skeleton that they found in Ethiopia that's something like 2.3 million years old. And actually one of the first asteroids they're going to visit on their way out to the Trojans is an asteroid that's named after the archaeologist or the anthropologist that discovered the Lucy skeleton. And I unfortunately can't remember his name now, but somebody probably has
Johansson? Chuck Johansson?
No.
Yeah, sounds reasonable. I know there's a J in it.
Yeah.
So it's a 12-year mission, and they're going to actually zoom by the Earth a couple of times to get enough energy, steal some energy from the Earth to go out that far. And they're actually going to come back again and then go out when they're switching between the two Lagrange points of these Trojans.
Mm-hmm.
The Lagrange points are pictured on that diagram. That is Jupiter's orbit.
Ahead and behind, 60 degrees.
Well, actually, three-dimensional. They can be up and below, and that thing is an ellipse, not just an oval.
Yeah, it's an ellipsoid. Yeah.
Yeah, right.
And so it's got to be gazillions of miles away, but it's still in Jupiter's orbit, and they never intercept the planet. They just go on the same trajectory and speed.
Those are stable points. Yeah.
Right. So in any two-body system, there turns out to be 5 Lagrangian points. Okay. And these are the two that are basically 120 degrees apart. okay, that are there because of Jupiter and the sun. Okay,
They're also the two stable points. The others are not stable.
that's correct. Yeah. So there's 5 of them. So in a 2-body system, there's those at 120 degrees you can see here. Okay. There's one in between the sun and Jupiter. Okay. One on the other side of the sun away from Jupiter, and then one on the other side of Jupiter away from Jupiter. Okay.
Away from the sun.
Yes, correct.
Yeah, the one that's far out from Jupiter, well, there's a similar one from Earth, and that's where we're going to put the James Webb Space Telescope.
Right.
Now, Tom, you said there was one in between the sun and Jupiter. Is that the regular asteroid belt?
No,
No.
Oh,
No.
okay.
So-
Well, there is a belt
Yeah,
out there between those 2 planets.
Yeah, I don't know if Tom can pull up, Tom, if you might be able to pull up Lagrangian points for just 2 bodies, then it'll show it better than just, talking about it.
Yeah, the one that's in between the Earth
Oh,
or
okay.
the body and the sun is not stable because depending which way
Right.
it gets closest to, the 1 over r squared rule from gravity takes over and pulls it into that body.
Right. He got a beautiful diagram here. Okay.
All
So in this particular one is for looks like the Earth and the sun. Okay. And these basically represent points where the potential is very weak. Okay. Gravitational potential is weak. Okay. And it's quite a ticklish calculation to calculate all 5 of these. Okay. It's easy to find L1. Okay. It's a little more ticklish to find L2 and L3 and then L4 and L5. Okay. But there's always 5 of them. Okay. So
and that's for the
did this.
asteroids trapped in these.
Yeah,
in
go
these
ahead, Chuck,
points.
go ahead.
One set is they're both called Trojan asteroids of Jupiter, but one set is named after the Greek participants in the Trojan War in general, and the other side in general is named after the Trojan participants in the Trojan War. Although each group seems to have a spy.
Well, do we have a couple of asteroids tailing us in our orbit?
Yes, we do. We have some that come occasionally and hang around the Earth. They're not in Lagrange points, but I think we might have 1 or 2 in Lagrange points also.
Yeah. That's another great figure Tom pulled in. That's for the Earth and the sun.
Okay, and that's where they're going to put the Webb someday, right?
In L2.
Yeah, L2. Mm-hmm.
So it's going to sit
That's
there.
also not a stable orbit, so they're going to have to do station keeping.
Yeah.
I just don't
The
understand.
stablest one of the bunch, I believe, is L1, right, Chuck? The stablest one of the bunch is L1.
You got me.
Okay, I remember doing the calculation, but that one's easy to do because all you do is you look for basically the gravitational force to vanish, okay, between the 2 polars, the sun and the Earth in this case.
Huh. So when you say the asteroids in the Trojan belt around Jupiter go back to the very beginning, they were never a big solid body that broke up?
No, and neither were the normal asteroids, but we think the normal asteroids have more mixing going on with stuff from the outer solar system and collisions and things like that. We think the ones in the Lagrange points for Jupiter have been stable and in those orbits since the onset of the solar system in general.
But the problem I have with that, from just, I hope, common sense, is how in the world do those dinky little clumps of gas or dust form hard rocks with that little gravity? They need to be in a big round ball like a rocky planet, don't they?
No, the electrostatic forces can stick them together, and then you have all kinds of stuff going on with protons from the sun and radiation hitting them that can fuse things together.
Really? And make pieces of granite that are totally solid. Well, what's Lucy
Probably
going to
not
do?
as tough as granite, but
Okay, well, but they're hard. You have some of these suckers.
right, and they're pretty crumbly.
Well, did you guys touch on just real quickly last week the poor lady up in the town of Golden,
Yep,
British
in
Columbia,
Canada.
who actually woke up with a meteorite next to her on the bed?
Well,
On the pillow.
It came through the roof and it ended up in her bed, but under a pillow. She didn't know what had happened at first. And she called the police and they came and saw the hole in the roof and they found it under her pillow. She hadn't really noticed it was there at first.
Wow.
And they thought that it was blasting from a nearby construction site. So they went to the construction site and they asked them if they'd been using dynamite recently. And they said, no, but we did see this big, meteor. And that's when they put 2 and 2 together.
Wow.
And was it older than dirt?
It's a chondrite, so it's one of these ones that formed from little bits and bobs and hasn't been modified by melting.
And left a hole in her roof, I
Yep.
assume. Wow, that's an incredible story.
Yeah.
I haven't seen any pictures of any of that. Have you? Just
Well, here it is, right here. Tom's got them
Yeah.
up, especially the ones he just scrolled away. Yeah, right here. Here it is.
I'll be danged. I'll bet you it's hard as hell and heavy as all get out.
No, it's a carbonaceous one and a chondrite, so, or at least a chondrite. I don't know if it's too carbonaceous, but you can see it. The chondrites have this structure where they're just an amalgamation of a bunch of little things. So they
What's
look like
that?
granite, but they're nowhere near as tough.
Yeah. What happened to the 5-pounder you used to lug around to all our star parties? Is it back in the shelf?
Yeah, I bring it out to when we do some stuff. I mean, it's hard to hand something around in COVID.
Yeah. Yeah.
Yeah. Jerry Wilson, we
It's
met
not
you.
hard to hand it around. It just transfers it.
Yeah.
Yeah, we were going to write you a pandemic version, a change of your whole little speech there.
Yeah.
Nicola
Well, we used to call it
Vegas.
the flu rock anyway.
Oh, that's absolutely right.
Blue rock.
But here's what I would like to know, getting back on subject, what is Lucy going to do in 12 years? That's a long time. Some of those guys might not even be around when it arrives there. What's it going to do? And how's it going to go from area to area? From
Well, you can
Lagrange?
see here that the diagram that it's going to use the Earth to steal some momentum. It's going to make close passes by the Earth to transfer between the points. And it's going to spend most of those 12 years traveling from one spot to another. They're
Okay.
going to go within something like 70 kilometers of some of these asteroids and get, not only pictures, but spectral measurements and chemical analysis.
What do they call that when they pick up a little speed? A planetary lift? When it goes around a planet?
Yeah.
Slingshot.
Slingshot?
Slingshot. Did the Voyagers use that to go on their way out of the solar system? The 2 Voyagers?
Yes.
I don't think the Voyagers did, but things like Cassini did.
Okay.
No,
and this-
they used it to do a grand tour.
Yeah,
Hey, President Jerry's back. Hope you stay with us.
that's right. For the Voyagers, they used Jupiter
Okay.
to sling them
Well,
out toward the outer planets.
Let me get this quick question out of the way. Tom Whittemore alluded to the fact, I think he said that any 2 items, any 2 things, one of them forming an orbit, that would be Jupiter and the sun, gets the Lagrange point asteroids. Do all the big gas planets have them? Are they also around Saturn and in Uranus's
I
orbit?
know they've found some around Uranus. I don't know. I mean, potentially they're around all the planets.
Mhm.
Do they ever fall into the planet and give us a Shoemaker-Levy black spot on the planet's
Well,
surface?
Those are
Nope, they don't.
generally stable points. If they interact and one slingshots another in there, that could happen. Yeah.
But they're scattered out. They're not like a flat ring around Saturn on a large
No,
scale, right?
no.
They're everywhere.
No, they're clumps.
Clumps. Some are above, and that means they have slightly different orbits,
Yes.
tilted. All of them have different. Geez, you'd think you'd see collisions that would light up the sky every so often out there.
Space is pretty empty. I mean, it looks crowded when you shrink a diagram down like this, but there's a lot of space between them.
Are they
Look at
different? Go ahead.
I was going to say, look at Saturn's rings. You look at the sci-fi movies, and the spaceship is weaving its way through the particles. They're like 1,000 miles apart. In reality,
Really?
yeah.
And yet it gives us that bright a ring.
Well,
A
most
lot
of
of
them are
them.
really tiny.
Yeah, they're dust from collisions amongst themselves.
Well, I know there's Star Wars scenes where they're dodging the
Yeah.
asteroid belt.
That's Hollywood.
Yeah,
I
that's
know.
theater.
That's
Yeah,
right
the
along.
average distance between asteroids and the asteroid belt, between asteroids of any appreciable size, let's say a kilometer across, is something like 1 million miles.
A million,
Okay.
okay, not even 1,000.
Yeah.
And yet there are hundreds of millions out there. if
Yes.
Not billions. Wow. Are they different in the Jupiter orbit than the asteroid belt?
That's what we think, that they're more primitive. They're more reflective of the early solar system.
Why do you suppose asteroids don't have a lot of water in them like comets that are out in the Oort cloud?
Some of them do.
Some of them do, but they
That's
never
what causes
become.
the tail.
What?
That's what causes the tail amongst the, when it starts to get warmed by the sun, all of the volatile stuff starts to evaporate, water being amongst them.
Right, I understand that, but you never hear of an asteroid becoming a comet, do you?
Sure.
Do they? Really?
Sure, there are active asteroids. But see, they're in a region where they get heated enough that a lot of the surface stuff is gone, as the volatiles have already gone away. It's only when you get something that exposes that suddenly that you tend to get an outburst among the active asteroids, like a collision or some
All right.
something that disturbs them.
Series of collisions, as you all know, gentlemen, happened back in the 90s, named for Shoemaker and Levy, a couple of astronomers. Do you suppose that rock, whatever it was, an asteroid or a comet, came?
That was a
from
comet.
Was it a comet?
Yeah.
So it wasn't from the Trojan group.
No.
It just came from the Oort cloud, perhaps, way out, or Kuiper belt.
Yeah.
I see. What are we looking at now? Is that the regular
notice-
asteroid?
Chuck was talking about Trojans and the Greeks ahead of Jupiter. And then it looks like there's something called Hildas out there as well, just outside the asteroid belt.
But
They're
they're
at the
in that
180
far
degree
away. They're
point.
in that other Lagrangian point. They're in that L3 point.
Oh, yeah. Yeah.
If any of these rocks were not in the so-called Lagrange points, your L2s and 3s and 4s, let's say they were up at 3 o'clock on that, or 2 o'clock rather than at 5 o'clock and 9 o'clock, the green, would they be pulled to those other spots? Is that how that works? By gravity?
It would not be a stable orbit. They could end up, anywhere depending on what their vector is.
But the key
if Jupiter in its orbit is at 12 o'clock, then the Trojans will be at 10 o'clock and 2 o'clock.
Oh, really? That's okay. Well, Jupiter.
Well, they travel in orbit around with Jupiter. They're always in the same respective location with respect to Jupiter. That whole system is rotating.
I'm just trying to understand, Bruce, this Lagrange thing. Why they clumped there? What's going on?
Because the net gravitational force on them is very small. It cancels out between Jupiter and the sun. That's why.
Okay. Even though it's on the platter, the ecliptic of its orbit, it does kick in.
The plane of its orbit, yes.
Do you suppose in ancient times there were more of them closer to the planet and they all got sucked up, or they all clumped together over the millions?
Well, yeah, if they're not in those spots, they're not in stable orbits, so they would tend to get thrown out.
And as you said earlier, Chuck, there are smaller versions of this that we don't even really care about around a Uranus or a Neptune.
Yeah,
they've
been found on some of the outer gas giant planets.
These damn
It's
little
not that
rocks.
we don't care
everywhere.
about them. It's just that they're awful hard to get to.
Okay. Are they going to try to land on one in 12 years?
No,
They're not.
no.
Just going to visit.
And 12 years is the entire mission. So they're actually going to reach one set of the Trojans earlier than that. Then they're going to pass through that, come back, pass by the Earth again, and then get slung out to one of the other Trojan points. So it's a strung out mission. It's not like in 12 years they suddenly arrive there. There's things that are going to be going on during this time.
Right, because that orbit is giant. It's several trips into space.
It's 500 million miles out there.
Okay. And Saturn, which is the second biggest, doesn't have a formidable bunch of Trojans of its own?
Not that we know of, but it may have some.
Well, the Cassini didn't let us know that, did it?
Well, Cassini didn't go anywhere near the Lagrange points of Saturn. It went to Saturn.
Okay. It's amazing. Who is this guy Lagrange? Was he a pretty good
French mathematician?
Mathematician, yeah.
Wow, look at that. Amazing. Well, this the latest. Lucy, I heard that something having to do with the Beatles was involved. Did they play it during the launch? They didn't put it on the spacecraft, did they, Lucy, in the sky with diamonds?
One of the instruments on the spacecraft has a bunch of diamonds incorporated in it, industrial diamonds that they made, probably because of their spectral characteristics. I don't remember what the instrument was. It's probably in this article. But that's why they played Lucy in the Sky with Diamonds.
Probably stuff our president made back in the 80s out at Santa Barbara Research. Look at this. What are we looking at, Tom?
These are some of the instruments that they're using. Look, mostly spectral.
That's the Lucy. That's the Lucy spacecraft, huh?
Pieces of it.
Oh, pieces of it. What's the problem they're having right now, even though it's only a week up?
They have 2 solar panels that are very large. I think they're something like 27 feet across each.
Right.
And they unfold like a fan, like a circular fan. And one set, they both deployed and they unfurled, but one of them didn't latch in place. So they're not getting the signal that it's latched. And it's all working. But they don't want that, some maneuver that they make to cause that array to flap around. So they're not doing anything right now, but I think further on in the mission, they're going to fire their thrusters to give a little jolt to try to latch that final panel.
Artist Rendition there has it next to a giant asteroid already. Wow.
Yeah.
That may never happen, getting that close.
Oh, they're going to get within something like 70 kilometers. So yeah.
And those round solar panels, they just power the instruments. They don't propel the machine at all. Right?
I don't know if they have an ion thruster. If they have an ion thruster, yeah, that's how they'll power it.
Really?
Yeah.
Solar panels turn into ions somehow?
No, the electricity is used to generate a magnetic field that accelerates ions out the back of the spacecraft. And they pick heavy elements like xenon, and they accelerate the ions out the back, and that's like throwing ping pong balls out of your canoe.
Yeah.
So there's Donald
But you have a lot
Johansson.
of ping pong balls.
Yeah.
There's Donald Johansson there. That's the guy that found the Lucy skeleton, and so that's the first asteroid they're going to visit on their way out, and that's a normal asteroid in the asteroid belt.
Oh, they're actually going to go through the asteroid belt and stop some of those. Which one is Johansson? I can't read it on my
It's a
screen.
little tiny one on the
Little
right.
tiny.
Oh,
Yeah. I had a chance to see Lucy when I was in Cleveland. She was displayed at, I think, at the Cleveland Museum of History or something like that. Yeah. So I actually saw her bones.
Yeah.
Oh, Lucy, there's not much of her, is she? Was a tiny little thing.
In this picture, there are Patroclus and Menecius, the 2 big asteroids that were shown there. That's actually a binary system. They're close together. They orbit each other. And just this last year in May, I think it was, or June, there was an occultation that they did. And there was a campaign all across the US to observe this. And I got one of the chords on Patroclus. And then Menecius went farther south, so it was going through Texas, and some people got chords on that one.
You know what's fascinating to me, gentlemen, about the binaries in the universe, whether they're stars or rocks like this? At some point, depending on the size of the 2 units, because big or small or same size, one of them is only a moon when it's going further and more revolutions than the bigger one. Do you follow what I'm saying? At what point does a partner in a binary become a moon? Is there a limit there? Do you know what I'm talking about?
I think the definition they use is the center of mass of the system within one body or not? Okay, like for us, the center of mass of the Earth-Moon system is within the Earth. So the Earth is considered the major planet, and the moon is the moon.
Okay.
Okay, for 2 of these that are almost the same size and same mass, then the center of mass would be between the 2, and you would consider it like a double planet.
Our sun has its center of mass going around inside it, right?
The center of mass of the Earth-Sun system is within the sun, yes.
Yes.
Okay. The sun has never scooted out of its position by,
Yes, no, it is.
Oh, yes.
but not beyond that point of center or whatever you want to call it.
It's orbiting around that center of mass. So
Right.
that's how we detect exoplanets. We see the stars move back and forth.
Right. And one of the calculations I was teaching astrophysics at Westmont is, as you can imagine, Jupiter has the most influence at making the sun, quote, wobble, making it wobble. And you can calculate that it moves about 5 meters a second around the center of mass. So the sun actually wobbles around its center of mass. Thanks mostly to Jupiter.
Wow.
The simulation that we presented at the December meeting, 2 years ago, myself, Farshad Barman, and oh, come on, I can't remember his name. Anyway, I emulated the position of the sun over, I think, was 1 million years, and it has a locus of points that's about equal to twice its diameter.
And here's a
Yeah, you can
diagram
see that
here.
one. Yeah, the same thing. Yeah, right. Similar.
Well, now, something I recently stumbled upon in a YouTube video, you can verify one way or the other. One of our closest stars, it's number 6 or 7 away, Sirius, the bright one.
Which diagram are you looking at?
Actually, I'm bringing up something new, but it's on the topic. Are you back with us, Jerry?
Can you hear me?
Yeah,
Yes.
I don't
Which
see.
which diagram was Bruce referring to?
He made one, and then also the one that Tom currently has up is showing solar wobble.
Tom has about 30 up currently.
Well, yeah, it just has one big one showing the solar wobble.
Wow,
Oh,
all those circular movements on the screen represent different planets' effect on the sun. Is that what we're looking at?
That's, yeah, in effect, that's the net effect as the center of the sun moves around like this.
Okay. And the closer in size the two objects might be, obviously it's not going to be interior. It's not going to be inside either object. They're going to actually be going around each other, right?
Right. That's when you consider it a dual planet.
Okay. Can I bring up what I heard about Sirius and you tell me, is Sirius a binary at least?
Yes.
Yes.
My understanding was it's a big one, a big star. I'm not sure if it's a red giant or a big.
No.
No,
No, it's a main sequence star,
Oh, okay. But there's also a smaller one,
a white dwarf.
a
Right.
white dwarf, and there might be a third.
I don't think so.
All right, they don't know, at least according to this, and it's amazing how many thousands of years it takes for them to go. What are we looking at now?
Sirius is called the dog star, and its
Okay.
companion is called the pup.
The pup. Yeah.
It's
I think
supposed-
Barnard, E.E. Barnard was the first one to see the pup star in the late 1800s. I think he was at Lick Observatory. Sound good, Chuck?
Yeah, either there
Barnard.
or at the U.S. Naval Observatory, somebody saw it, but it
Yes.
was with a new Clark refractor.
Yeah. Ha.
It's in the southern sky, but we can still see it. The southern.
yeah.
Well, it's south of the equator,
Easily.
the projection of the equator.
It's the brightest star in our sky.
Even though it's below the horizon.
No,
Not
no.
below the horizon.
Oh, it's not
It's
below the
below
horizon.
the projection of the Earth's equator in the sky.
Right.
Oh,
And a fun way to look for it is to take the belt stars in Orion and they'll point towards Sirius. And as Chuck taught me one night at Outreach, the belt stars point in the other direction to the Pleiades.
aha. And it's about 8.5 light years away, which makes it number 4, 5, or 6 in
Yeah.
closeness to us.
Yeah.
Fascinating stuff.
It's kind of the closest one you can easily see.
Mhm.
Chuck, if you don't mind, I'd like to direct, first of all, question, have you been doing any occultations of asteroids over stars lately in the middle of the
Yeah.
night?
Mhm.
Tell us about it. Who got eliminated for a few minutes from the sky? What star?
Well, I've had a bunch of negatives recently, but I've been averaging 1 or 2 a month positives. And the
Wow.
last one, I don't remember the name. It was just a brief occultation.
At what time of the morning?
About 3 a.m. That's probably why I don't remember.
I would be
You can-
giving up after a few no shows. I would probably give up getting it up in the middle of the night, unless you can't sleep like me sometimes, I gotta tell you.
It's the thrill of the chase, really.
And you
Yeah.
keep a record
Coming
of
up
all of it.
tonight at about 8:30. I'm hoping the sky clears by then. We'll see.
I see. Okay, now can we lead off of this, my friend, into something I couldn't believe when you said it earlier before we went on. They have discovered an exoplanet in another galaxy. How in the
Yes,
world?
it's called an extroplanet. They add an
Exoplanet.
R. Instead
Wow.
of exo, they add a TR, extroplanet. in the Whirlpool galaxy, which unfortunately right now is not in an area of the sky that's easy to observe. But what they saw is, as you can see in this picture that Tom just put up, there's a blue giant star in a close orbit with a neutron star. And the neutron star is sucking the upper atmosphere off of the blue giant. And it has an accretion disk that's an intense source of X-rays. Okay. So they've been able to detect this X-ray source in the galaxy, which is 28, 30 million light years away. But what they saw is that it's periodically interrupted by something. And what they think that something is a Saturn-sized planet in orbit around the binary system. And it periodically, from our point of view, blocks out the X-ray emissions.
Really?
So this is an occultation, but it's an X-ray occultation in another galaxy. So it's a potential exoplanet. It's not confirmed yet, but pretty cool.
Okay.
So with X-rays, you can have a higher resolution than with visible light or infrared. You actually get higher resolution with X-rays than, of course, your X-ray telescope. I don't know. What do you think?
Yeah, theoretically, I think it's, because it's so hard to focus it. I don't know. Jerry would know better what kind of resolution they can get with X-ray telescopes, but it's probably pretty good.
Wow. Is it my understanding that X-rays have wavelengths that are about the size of an atom, the thickness of an atom? Is that they launch that often, that incredible amount of their photons, right?
Yeah.
They're just,
with a really high frequency.
But you'd think at that speed, a mile wavelength would be incredibly powerful, but a thickness of an atom, and then gammas are above or below those, less or more. Smaller. Wow, considering it's so hard to see exoplanets in our galaxy, to see one in another, and do they assume
Gammas are smaller?
What?
Gammas are, you can see, here's the diagram. So X-rays are about the size of atoms and gamma rays are about the size of nuclei.
Right.
Jeez. Wow. And what drives me nuts is trying to figure out what powers that, what makes that happen,
Well, that's the amount of energy in the photon.
It just decides it wants to go that lickety split one right after another, and it's got to be a lot of energy. And as that comes into your teeth when you're at the dentist's office, that exacts, but a low version of it for whatever that's worth. Amazing stuff. So they got pictures.
Now with the modern detectors they stick in your mouth that aren't film, they're actually solid state. The exposure is like 1/1000th of what it was with film.
Yeah.
Much safer.
You suppose they had a period at the early part of dentistry when they had those, when people actually got cancer or had a problem?
Well, yeah, sure. You remember Richard from Judge for Yourself, Richard Dupre.
Okay.
I mean, he was back when they thought X-rays were a great way to treat acne, and that's why he had so much cancer problem. It's because when he was a teenager, they had treated his acne with X-rays, with intense X-rays.
Oh wow!
They did the same thing for warts.
Yeah.
Or warts.
And isn't X-rays the best way to check the size of your feet too?
Yeah, back in the 50s.
Back in the 50s, but so many people got cancer of the toes, didn't they?
Who knows where they got it? I mean, that would go all the way through you.
I always wondered,
Because you stood on the machine and you looked onto the fluoroscope screen, so the X-rays came up through your feet to the screen through the rest of you.
Well, I always had problems when the technician, the assistant in the dentist's office, put a lead vest over me and left the room so that it wouldn't go into my torso, but it went right through my head. Give me a break, lady. She didn't put anything over my face.
Oh, that's what happened.
You wanted to be able to see what was going on in your mouth.
Well, I know that, but what?
So that's what happened to you.
You have any jokes of the week, Tom Whittemore?
Well, that was one.
Oh, that's true. That was a good one. Thanks. We had a bunch of silly stuff sent to us by the president. Are you with us, Jerry?
Yeah.
Oh, well, I don't see you because they pare it down to only 4 of us on the side one. But there we go. Feed, good Lord. There was also
Ron, I'll show you one of Jerry's pictures here,
Cartoon?
one of his comics in just a second here. Let me
All right,
stop
well,
this.
All right, while you're
and I'll
doing
sh-
oh, there
I'll
he
show
is.
you. I like this one.
Oh. A little fake out. That's what they were doing. That's crazy. You know what the Pentagon calls them now? Not UFOs anymore. What are they? UAPs.
Unidentified aerial phenomena.
That's it. That's what we're looking at. From I guess what is it called? The incredible movie that I always like, Close Encounters, the Third Kind. President Jerry, you look comfortable. Are you with us?
Just listening to the rain and you guys.
Well, we can talk
Which
soft.
is more interesting?
Yeah.
Definitely you guys.
Well, I missed out on your photon detection thing, the special series focusing on the basics of how our telescopes work. And
Well, cameras.
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 I'll
Yes.
give a recap next week.
Okay, we'll be back. You'll get a new modem.
We got a new modem and we got a new router. The modem works. We haven't been able to hook up the router.
You have an expert over there at the house helping you?
Yeah, Pat.
Oh, bless her.
Pat,
She's
Pat
been
and Honey
working
are
on it since
conspiring.
Saturday.
Well, when she's done with you, she can come over here to me, I guess.
Yeah, right.
We got
Well,
11
we have an IT expert we're going to hire for money that comes over and bails us out in times like this.
I got to tell you, I hooked into your Tuesday workshop podcast the day after last week on Tuesday. Tom called me to see if my stuff was working, and there was a gentleman that started the program, Tom, and it looks just like Jerry looks right now. He was laying back in a big lounger in his living
That
room.
was Dick Beam.
Beam.
He's got a bad back, so he has to lay down. Yeah.
Yeah.
Well, I felt sorry for the poor guy, but here you are, either comfortable or you're hurting.
No, I'm just comfortable.
Okay, you look comfortable.
If you want me
Feeling
to sit
better?
up, I can sit up.
I had a problem with sciatica, and I went to my primary care physician, and he prescribed prednisone. And I mentioned that to Dick, but this was only a 6-day course. You get the pills, they're 4 milligram pills, and they're a little bubble pack. The first day you take 6 of them, next day 5, 4, 3, 2, 1, none. And it just got rid of it. Boom. He said 2 things, my GP. He said, put me on a antibiotic too. He says, you could have an infection someplace in your body that is also causing inflammation, and it's systemic. So let's treat that. So they gave me Keflex, and then he prescribed this 6-day course of prednisone, and it was magic. And I mentioned that to Dick, but he said, well, I don't want to take a corticosteroid. But that's for people that are a long-term use, like Jerry Lewis, the comedian, was on it, and he had the moon face, and there's a whole lot of side effects.
Yeah.
But 6 days worth don't do that to you. They just solve the problem.
So
Bruce,
this
it
has
was-
been an
it was-
advertisement for Sirius XM, the Doctor Radio. Please tune in.
It was science, not magic.
Yeah.
Well, we all get sciatica at some point. There's some nerve that I don't understand. It's along
It's
the
called the
outside of it.
sciatic nerve.
So
Runs
let's-
down your back, over your butt, and down your leg.
Don't have it all the time, thank God, but I'll remember that. We slip into a compare maladies medical program here.
Yeah, you can tell it's a bunch of old astronomers.
Do we miss the luncheons? I know we missed the meetings.
Yes, I missed the luncheons.
Yes.
Now, the museum is talking about opening up the planetarium again sometime in late November.
Well, that'll
And,
be,
also, Jerry, I heard from Colin that there's a new accountant at the museum, and they want to get together and have a meeting with everybody about the accounts. So you'll probably be hearing from Colin.
Okay. Thanks for the heads up.
he wouldn't mind stepping down, but in the meantime, he is picking up our mail out there, right, at the museum.
He's doing everything. Yeah.
Yeah.
Ooh, did any of you see all the mail? Did we get a big stack of stuff that nobody?
He
Got
said there's some mail, but not that much.
Okay. A lot of it was renewals. Can we talk about how we're handling that? People signing
Well,
up?
we're not doing renewals. He just sends people back and says, no, you know, since we're not meeting.
We froze the situation.
Yeah.
How does that compare with other astronomy clubs in Ventura and up north? Are they
Who
all
knows?
pretty much?
I don't know.
Tom has popped up a current night sky kind of, and there is the Pegasus cluster is M15. That's a globular cluster that has a black hole at its core. And that's high up.
Oh.
Also high up these days. This is like prime time for observing the Andromeda Galaxy, just for anybody who's thinking of something to go look at, even in binoculars.
And M33.
And M33, but that's tougher.
Yeah.
But M31, the Andromeda Galaxy, if you find Cassiopeia in the sky, which is kind of the squished W over there to the left in this image, you can see that nice triangular part at the top of the W looks like an arrowhead, and it kind of points over to where the Andromeda Galaxy is.
I always use the great square Pegasus, and I come down 2 bright stars, and I go up 2 fainter stars, and that gets me close to Andromeda.
Yes.
Well,
Now, I can remember at our outreaches before LED streetlights, Martin Meza he could see Andromeda, you know,
Naked
a
eye.
lot. Yeah,
Yeah.
naked eye. But you can't see it anymore, naked eye.
Oh, he's
have
still
to get
doing
away
that
from
pretty
here.
good.
Yeah.
I see.
The star Merock is right halfway between the Andromeda and Triangulum.
Right.
So if you can find Andromeda, you go equally the other way to get to the Triangulum galaxy.
But be aware that Triangulum is much lower surface brightness. So
Yes,
you have
right.
to have a dark sky and you have to look carefully.
And
We
you
see
have to
it
have
here
telescope.
in the backyard, Chuck. I can see it here in the backyard
All
easily.
right. You got a dark sky.
Yeah. The other thing about, you see Merock there, an Andromeda Merock.
Yeah.
So some time ago, there is a galaxy in the background of Merock. It's called the Ghost of Merock. And on a good night with the 8-inch at Westmont, I sometimes can get that galaxy for people.
There it is, Merock's ghost.
Yeah, the Ghost of Merock. That was Steve. What's his name? He lives in Hawaii. He's a really good.
Steve O'Meara.
O'Meara, and Jerry has met him. Yeah.
Yeah.
Mhm.
And if you zoom back out again, Tom, if you continue down that line of stars, there's Almach.
Mhm.
And
Beautiful.
Almach is a beautiful double, kind of like Alberio, blue
Right.
and gold, but much closer.
Yeah, very beautiful.
Well, are you two gentlemen that do those sky shows in Gladwin Planetarium going to have to relearn your craft and go all over this? And
The museum is
Yes.
setting up a relearn the planetarium session on November 13th.
I see. Wow.
it's been a year and a half, I guess. Just
Yeah.
So they're recognizing our ability to atrophy.
Yeah.
well, you
Well,
said
it's a new person, I think.
Oh.
I don't know if they're even this person is even aware of the AU. We'll see.
Oh, geez, that's nice. It's not that lady sent the notice out, Carolyn. No, what is her name?
Yeah, Carolyn. That's our
It is
secretary.
Okay, well, she knows about it. I'm sure.
Yeah.
Do you guys want to talk a little bit about outreach and telling stories at the eyepiece?
Yes.
Yeah. Good, good.
Sure.
Tom, is there any way, Tom Totten, is there any way you could get NGC 1647, please?
Okay. Let me-
In
So
Taurus.
this, yes, it's in the between the horns of the bull. Okay. So in the December issue of Sky and Telescope, there's a really wonderful writer named Matt Wedel, Wedel, and he always does the binocular highlights thing in the middle. And it turns out he's a paleontologist, and it just inspired me, like how you can talk about distance scales and time scales at the eyepiece when you're showing folks things through your telescope. And he mentions that the 1647, NGC 1647, it's an open cluster in Taurus. And he mentions that one way to think about it, because he is a paleontologist, these stars are about 160 million years old, which makes them quite young. Okay. And what he mentions is that what he likes to say is that the light from these stars was basically born okay, when Diplodocus and Brontosaurus and all the dinosaurs of the Jurassic period, okay, were stomping around the Earth and we were nowhere to be seen. It's just a really interesting way. If I were to show this to people in a telescope, I would say stuff like that. It's just a nice way to think about scale, you know.
Oh,
They're
And, you know,
showing that.
all of us have these stories, right, Chuck? We all have kind of cool stories, but it was because he's a paleontologist and he studies dinosaurs.
Yeah,
He
it's a
he
time
mentioned-
scale. Yeah.
Yeah.
Another cool one is Alberio, which is the nice double in the beak of the swan. And that's a little over 400 light years away. So that light left when Galileo was looking at the sky. So that's another cool story.
Yeah.
wow.
There are some times when I show, I think it's Castor, I'll say, you know, this light started its journey when Hoover was our president.
Mhm.
Well, how many star clusters are up there on the ceiling in any program, any show you do? Just curious.
Thousands.
Oh, tons, yeah.
Your M's and your NGCs, a lot of those are just star clusters.
Yes.
Mhm. That particular one is an open cluster, and NGC stands for the New General Catalog.
But they
It was
don't
new
all,
in 1885.
uh-huh. But something Chuck mentioned caught my attention a second ago. They don't all have a black hole in the middle of them, do they?
No,
No.
Very rarely.
especially not open clusters, but globulars
Right.
may.
Yeah, globulars are very old, Ron.
Or what's the
Open
difference?
clusters in
between-
general are fairly young.
What's the difference? Open and globular.
Opens are young new stars, loosely gravitationally bound, and globulars are old stars and very dense, so strongly gravitationally bound.
And the one you just mentioned that had a black hole, which is it?
That's a globular. That's an old one that's dense.
Right.
And we-
The M15
Yeah.
in Pegasus, it's off the nose of the horse. The nose is called Enif.
Yeah, and that globular is actually dimly visible if you're in a very, very dark site. And there are
Mhm.
Arabic, desert dweller stories of the fly around the nose of the horse.
That's pretty good, Chuck.
Wow, man, I don't know. If you could track the orbits of all those stars and most of those clusters, it would just be a big ball of yarn, wouldn't it?
Yep.
Mhm.
Well, anybody got something to add at the very end? This is another great show. Didn't have any talking points to start with, but we'll continue Jerry's, I guess, series next week.
One thing for people with cameras, I think, or really large scopes, is there's a comet called 29P. So it's the 29th comet they found a periodic orbit for. It's called Schwarzmann-Vlachmann, and I'm probably pronouncing that wrong. 29P should find it in a program. It's in Auriga right now, the Charioteer, so it's up in the late, during the prime time at night, and it appears to undergo outbursts about every 58 or 59 days, and that seems to be its rotational period for the chunk of ice, and it orbits out beyond Jupiter, never gets closer than that. But it seems to have a hot spot or a cryovolcano on one side of it. And whenever that orbits around to point toward us, we see an outburst, or whenever the sun hits it, we see an outburst. And the comet gets quite a bit brighter. And right now it's undergoing an outburst, and it's jumped up to magnitude 13, which is pretty dim, but reachable with cameras.
Yeah.
And if you go to the British Astronomical Association site, they actually have graphs of its brightness in the last couple of outbursts, and they're monitoring it. So they have a great site where you can follow this comet and see what's going on.
Wow.
Well, now comets are dirty snowballs. You just described one that's all ice.
No,
I thought that's what you said. The ice, a big chunk.
well, it's an ice ball, but it's got lots of dirt in it.
Oh, okay.
Yeah.
It's a dirty ice ball.
Yeah.
They never dissipate entirely and just become gas in the tail and gone.
Well, some comets have gone away and just fragmented, and but there's always some rock in there. Sometimes they leave behind kind of the core body, and sometimes they don't. Sometimes they just totally evaporate.
Why do you
It just
suppose?
depends how much rock is in there.
And they're from the outer limits, the Kaiser or the
Kuiper belt, probably originally from the Kuiper belt or the
Oort
Oort
cloud.
cloud.
And they got the ice out there. The ones inside, they were like the asteroid belt, not much ice. Just rock pretty much.
Right, they're near the freeze zone, just where the sun's heat is enough to drive away volatiles.
Gentlemen, we've run out of time,
Uh-oh.
but it's kind of to have some rain outside, and it's not good viewing, but you know, we need some good mudslides now to replace those fires that we had. Jerry, heal thyself. You look good. You look comfortable. Can't wait to get you back next week. And all of you take care of yourselves and your beautiful lives, and do what we do is praying to Carl Sagan's ghost that we'll all get together again sometime, either at lunch or at a party. Thanks, Chuck. Thanks, both Toms.
Thanks, everybody.
Thank you.
Bruce,
Bye.
and we'll see you next week, Captain Jerry. Thank you, everybody.
Right.
That's it.
Thank you. Ron.
Bye.
Same time, same station, right?
Got it easy, Ryder.
Share our web page here.
Hmm.
All right. That's where we're at, folks. Check us out, sbau.org.